All right, we're on part 3. This is unit 2.5. I think I forgot to write that at the top. Right triangle trigonometry. So the first 6 questions you were just finding missing values using trig. So for each of these, I would look at my angle of interest. So here's my 34-degree angle. And then I would ask myself to label the opposite side, the adjacent side, and the hypotenuse. We know that SOHCAHTOA is the acronym we have for remembering these ratios. So if I look at my 34-degree angle, I have the opposite and I'm finding the adjacent. So I know that's my tangent. So the tangent of 34 degrees is equal to 2.5 over x. So to get rid of that division of x, I could multiply both sides by x and then divide both sides by the tangent of 34. And I now have x equals 2.5 divided by the tangent of 34. Make sure that you're in degrees, not radians. So click mode on your calculator. You should see degree or deg selected. If not, fix it. Now you can just do that in one step. 2.5 divided by the tangent of 34, we get 3.706. So x is approximately 3.706. All right, number 24. If we label this, we've got the opposite side. We know the hypotenuse. We don't know anything about the adjacent side, and we're solving for an angle. So opposite and hypotenuse is sine. So I'm going to say that the sine of x is equal to the ratio of opposite over hypotenuse, 41/65. And then I'm going to take the inverse sine of both sides. So the inverse sine is when you see that sine to the -1 power is what it looks like. The inverse sine of the sine of x, those cancel out and you just have x. But then you take the inverse sine of 41/65. So we get x is equal to the inverse sine of 41/65. We can just plug that in our calculator. Second sine is your inverse sine. Don't do negative sign. It's not the same thing. 41 divided by 65. We should get 39.107 when we round. So that's approximately 39.107 degrees. All right, 22. Let's see, 57 degrees, opposite side, adjacent side we are looking for, hypotenuse we know. So we're going to use cosine. The cosine of 57 equals the adjacent over the hypotenuse. So x over 25.8. These should be our favorites because when x is on top, I can just multiply both sides by 25.8. Cancels on the right. So I get 25.8 times the cosine of 57 is equal to x. I could plug that in, 25.8 cos 57, enter. We get 14.052. So that side should be about 14.052. All right, number 26. Now we have 2 variables. We're solving for 2 different angles. So we could use 2 different trig functions, or since it's a triangle, we could find one and then subtract the other from 90, because in a right triangle, the non-right angles have to be complementary. So the sum of interior angles is 180. All right, so I'm going to find x first. I'm going to just ignore y. For x, this is my opposite, this is my adjacent, and this is my hypotenuse. So I would say the cosine of x is equal to 6/32. I would take the inverse cosine of both sides. So x is equal to the inverse cosine of 6/32. All right, so second cos, 6 divided by 32. So we get 79.193 for x. And then we just want the complement of that for y. So in your calculator, you could type in 90 minus answer, and we'll get 10.807. So you could check that with trig, but if you didn't make a mistake when you found x, y should be correct. All right, 27, we're also finding an x and a y. This time they are both sides. So I am given this angle. This is my opposite. X is my adjacent. I'm going to go ahead and use tangent. So the tangent of 26 equals 2.5 over x. Multiply both sides by x, divide by tangent of 26. We get x equals 2.5 divided by the tangent of 26. All right, so in our calculator, 2.5 divided by tan 26, 5.126. Okay, so you could use the Pythagorean theorem to find y. The reason I wouldn't do that is you're now dealing with a rounded answer, whereas in the calculator, it's not rounded. So if you're going to use the Pythagorean theorem, I would seriously do 2.5 squared plus, in parentheses, 2.5 divided by the tangent of 26 squared, take the square root. That's a lot of steps. What's easier to me is to just find y using trig. So we could say the sine, because we would now be using the opposite in the hypotenuse, the sine of 26 is 2.5 over y. So 2.5 divided by the sine, of 26, can't type, we should get approximately 5.703. Now if you did that using the Pythagorean theorem and you got the same thing I did, good job. 28, last but not least, in this section, we're finding three variables, x, y, and z. Y'all, don't make it easier than it needs to be to find x. Use the Pythagorean theorem. X is going to be the square root of 20 squared minus 7 squared. You could type that right in the calculator in one step. We're subtracting since we already know the hypotenuse. So it's 20 squared minus 7 squared. If you do this in your calculator, make sure that entire expression is under the radical symbol. We get 18.735 when we round for x. Now, if you prefer to use trig or want to check it with trig, knock yourself out. You should get the same thing, but we would need to find angles y and z first. You can't do that with trig unless you know one of the angles. All right, so now let's find angle y. From y, 7 is my opposite and 20 is my hypotenuse. So I would use sine. The sine of y is 7 over 20. Take the inverse sine of both sides. Y is equal to the inverse sine of 7 over 20. All right, so inverse sine, 7 divided by 20, we get 20.487 degrees. All right, then to find z, we could also just find the complement of that. So I could do 90 minus 20.487. If you otherwise, though, wanted to use trig, we know that the only thing we'd have to change is we'd have to use cosine instead of sine, because from the perspective of angle z, 7 is not the opposite side, rather it is the adjacent side, and we know the hypotenuse never changes. So the cosine of z is 7 over 20. Take the inverse cosine of both sides. So the inverse cosine of 7 over 20 is z. And what we get is, in fact, the complement to 20.487. It is 69.513. So z is 69.513 degrees. Okay, 2 word problems. We are going to knock them out. 29, number 29, I'm going to read it. It says, it's finally warm outside, so you and your friend go to the park to fly a kite. You want to estimate how high the kite is flying in the air. You measure that the horizontal distance from where your friend, the kite flyer, is holding the kite strings to just below the kite. Did I make sense when I wrote that? Who knows? All right, here's your friend. Here's your kite. Trying to make it look like a kite we learned about. All right, your friend's holding the kite strings. I guess it really needs to be a straight line. And we know the horizontal distance. Looks like we're finding the vertical distance. All right, you also measure the angle of elevation. Oh, that's an important phrase. from where your friend is holding the kite strings to the kite itself is 40 degrees. So remember, an angle of elevation always comes up from the horizontal. It never comes like over from the vertical. So from this horizontal line up to the kite, that is your 40-degree angle, and that is critical that you understand that. If your friend has let out 9 meters of kite string, so we know that this string is 9 meters. Let's see, how high in the air vertically from the ground is the kite flying? Assume the distance from your friend's hand to the ground is negligible. Well, that was tricky of me because I told you measured that horizontal distance and then I didn't tell you what it was. Must have been late at night when I wrote this problem, but we don't need that information. We are finding the height, the vertical height. So we're gonna work backwards and let's see, we've got 40 degrees.
Hello, this is Dana.
We've got the opposite side and then the hypotenuse.
Oh,
so let's see.
It is not, but
we're gonna use the sine function. So the sine of 40 degrees. Sorry, my office mate had to get the phone.
Yeah.
The sine of 40 degrees is going to be h
it's
over 9.
Yep, no problem.
And h in this case is my height. So don't confuse h with the hypotenuse. I'm using that to be height. You can change it to x if you want. So h over 9, and then we would multiply both sides by 9. So 9 times the sine of 40 equals the height. So in our calculator, 9 sine 40 is 5.785. So the kite is 5.785 meters high from the ground. Okay, last problem. So I'm getting close to the end of the storage on my phone. If this video cuts off, I'll just finish it in a second video. 30. You are taking an early evening hike. You notice that the shadow of a tree is 18 feet long. So here's my beautiful tree, just like Bob Ross, and here's its shadow, 18 feet. Naturally, you brought your ruler with you while you're hiking. You also happen to know that the tree is only 11 feet tall. What is the angle of elevation from the ground to the sun at the time the shadow is formed? So if you have 2 angle of elevation questions on your study guide, your good student skills should probably alert you to that fact, and you might need to think that that's something that's important. So there's probably going to be something you need to know about angle of elevation. All right, so here's our tree. That's supposed to be the sun. It looks like a scrambled egg. That's why I'm not your art teacher, kids. All right, you want to find this angle. So again, it's critical you understand that the angle of elevation or an angle of depression always comes from the horizontal. So if you are down here, this is you,